Now, to know about the classical Hamiltonian, by definition, the classical Hamiltonian, which is equal to 1 over 2 of the total volume, d tau is the dv, and epsilon naught ex square plus mu naught hy square. Now, we know about the electric field Ex, we already defined uh, previously, and we also calculated the Hy in the previous lecture. Then we have the value of this and this. We must putting the value of this and this in this equation, and then we can get there are some mathematical expression. For example, v is equal to a square l. Then this Hamiltonian, if we put the value of Ex and Hy, and we have also d tau, because we have a cavity, then this cavity has length and this has area. If we consider the rectangular cavity, then this d tau, there already I have defined this d tau, which is equal to area and length dz. So here we can consider by considering d tau, which is equal to a and dz. So this a becomes from the area of the cavity, a divided by 2, and we have dz. And the remaining thing is the value of Ex by taking the square. And similarly, we have the same thing, mu naught and area, and we have already calculated the value of Hy, and by taking this, so we can get the square. We have the square of this square, and this must be the square. And epsilon naught, we have, forget here, we must have epsilon naught square. And now we can take only this part, sine k z, because the integration is along the dz. Then the remaining things can be can consider out from the integration. And we also know that sine k, which is equal to 1 minus cosine 2k jz divided by 2. This is very famous equation. Then we can put and dz, and here we can also take these things outside from the integration, and cosine, which is equal to 1 plus cosine 2k jz divided by 2 and dz. And now we have to take the integration of this thing with dz and this thing. So we have, and by taking the limit from 0 to L, then z divided by 2, 0 to L, and this thing, the integration of this, which is equal to this, from 0 to this. And this should be noted this, by taking the value of L and 0, then this goes to 0. And then the same integration can be solved, and this term will be equal to 0. And we have the value of putting the value of L, putting the limits, then z, this L divided by 2, and this L divided by 2. So we have this kind of equation. Further, if we know that the volume, which is equal to length and to area, then if I put the value of area, then this volume divided by L. So from here we can consider V divided by L. So here H, which is equal to V divided by 2L, and then epsilon naught, epsilon summation j, and the value of Aj, we know the value of Aj 2 nu j square mj, and divided by v and epsilon naught, and 1 over 2 and 2, because this is square, and q j square and L divided by 2. So this term, and the other term is A divided by 2, the same process, V divided by 2L, and mu naught epsilon naught square summation j, and where aj, the value of aj, we know the value of aj, which is equal to 2 nu j square mj divided by v and epsilon naught and q dot j and L divided by 2. So if you look at this equation, this V can be cancelled out with this L can be cancelled out with this, and similarly this thing and this L can be cancelled out, and also we can cancel out 2 as well. Here this can be cancelled out. So you have this 2 and this 2, and here also we have 1 over 2. Yes, we have 1 over 2 and 2, so this can be cancelled out, and this 2 and this 2 can be cancelled out. So further, this H will be equal to summation j 1 over 2 mj qj square mu j square, and plus summation j 1 over 2 mu naught epsilon naught divided by kj square. We have forgotten here q, we have kj square as well, mj and mu j square q dot j square, and then 1 over 2 summation j 1 over 2 mj and qj square mu j square plus summation j 1 over 2, and here one thing we can consider mu naught epsilon naught. The value of this is 1 over c square, and the value of kj square, this is actually c square divided by mu j square, and mj and mu j square q dot square j. So this is a very long calculation. So this c square will be cancelled out and this will also cancel out, and then we have 1 over 2 summation j mj and mu j square q dot square plus mj and q dot square j, and where mj and q dot square, this is actually mx dot, and mx dot is equal to mv, and this is the momentum, and finally this h, which is equal to 1 over 2 summation j and mj mu j square q dot qj square plus this is pj divided by pj square divided by mj. So from this pj divided by mj, so this is the final, the Hamiltonian This expression, the Hamiltonian of radiation field, this is the Hamiltonian for the radiation field, is a sum of independent oscillator oscillation energy. So this is nothing but this is the harmonic oscillator, like the equation for the harmonic oscillator, because